All right, in the lab this week, you run three, right? Three reaction. Reaction one, take a look. It's the add permanganate in basic solution. We use third butanol as a solvent. Okay. Reaction two, we call an oxone reaction. You add acetone, like the acetone that you wash, but it's a better grade. Okay. In solution, so which means in water, and potassium hydrogen sulfide, or we call oxone. Okay. And then do hydrolysis with hydrochloric acid. And the last one we call Woodward dihydroxylation. So we have all these reagent, silver acetate, iodine, acetic acid, and water, and then do hydrolysis with 10 molar sodium hydroxide and heat it up. So be careful this reagent, okay? Because at the high heat, sodium hydroxide can do some damage on your skin. So be careful and please wear protective goggles if in case that sodium hydroxide somehow in I don't know what happened. Somehow it gets on your eyes, so the goggle will protect you. All right. Now now you have to determine the product. Any of this can give you syn, can give you anti-addition or mixed addition. You will determine that using a TLC. Okay. All right. You'll be getting all of this. So you can have a couple plates of TLC, right? One for doing it, and the other one just in case you did it wrong. Okay, you're gonna put 1, 2, 3, 4, 5, 6. You're gonna make 6 lanes, if you could. All right, but try to squeeze them together. You make about 6 lanes. You need six lanes total. All right. You'll be given 2 pure compound of cis diol and then trans diol. Now you're gonna spot right here, cis here and trans here. Okay, so you're gonna see one spot. They appear, right? You see one when you develop TLC, you see one spot of cis, see the other spot of trans. They have different RF value, and you're gonna do cold spot, which means that you're gonna put one spot of cis and another spot of trans. And in this spot, you're gonna we will show you 2 spots because there are 2 compounds in there. Okay, the other 3 lanes A, B, and C, those come from the 3 reaction that you do. You run the reaction and take just a little of your reaction, just spot on A, B, and C separately from 3 reaction. All right, and develop the TLC with the solvent is in the handout. Now the last one, you're gonna go to visualize it with anisaldehyde. Okay, how to use that? Oh, you're gonna dip this into a solution of anisaldehyde, and then you're gonna heat it up with a heat gun. The TA will show you. You will do this. This is your job. You will do this. The TA will show you how to do this, how to dip or the whole plate to the solution, anisaldehyde solution, and then how to use the heat gun. They'll show you. Basically, gonna show up something like that. Okay. This is the TLC from different lab. This is not yours or expected result. It's not. I just took it from the website. Okay. Anyway, so the goal is to determine whether you get syn addition, anti-addition, or mixed addition. Okay. Give you some example. Let's say I do the first reaction, sodium permanganate reaction. All right. Let's say I do TLC and show one spot of syn diol. All right. So this is cis diol. So your goal is you go propose what's going on, what's the mechanism. Think about the like a few video earlier when we talked about syn addition. Right? What controls the stereochemistry of syn addition? Well, you probably have to think about the intermediate, something like that. So permanganate probably have to approach alkene on one side like that, right? You have to come up with the intermediate. Okay. However, if you run this reaction spot on TLC and you get trans diols, this one is anti-addition. When you propose the mechanism, what intermediate you have to think about? Trans anti-addition. Well, you have to think about the 3-membered ring like that. Okay, so this guy do something and make the alkene go through the 3-membered ring, possibly not oxygen on it, okay, because we use permanganate, right? But I mean, at least you have to think about an intermediate that control the stereochemistry outcome. Okay, and one more thing. If you get a mixed addition, you get all the three product. These two are enantiomer, so they have the same RF value. You're gonna say 2 spots. Okay. Anyway, in this case, you when you propose the mechanism, Well, what controls the stereochemistry of mixed addition? Think real quick. You probably have to think about the carbocation. Okay, so this reaction will pass through carbocation intermediate, something like that. All right. Basically, yeah, you can do the same thing. This is one reaction. You do second reaction. You do third reaction, and that's pretty much the whole lab. Okay. All right. We go back right here. So there are a couple of things we have to talk about reaction 2 and reaction 3 because you've never seen this before. Okay. All right. Let's take a look.